is what you doing at Epirus a platform business? And I said, sir, with all due respect, we've invented force fields. Do you understand what a platform is? I mean, yes, it's a platform. It could be worked into space applications, into airborne applications, into surface applications, land, air, sea, space, all of that. We're good to go.
Welcome to Research Radio, the official podcast of Contrary Research. Contrary Research is the best starting place to understand any private tech company. In each episode, we'll dive deep into the most important conversations and companies in technology. I'm your host, Kyle Harrison, General Partner at Contrary. For more info and to read our full reports, you can check out research.contrary.com. Myself, guests, and Contrary may hold financial positions in the companies discussed. This podcast is for informational purposes only and should not be used for investment advice. Drones have become a key force in transforming modern warfare. Global military spending on drones is expected to reach $45 billion by 2030. In the Russia-Ukraine conflict alone, each side was estimated to have used over 1 million drones in 2024. Historically, counter-drone efforts have been economically unsustainable. Modern militaries have been forced to use missiles that cost millions per shot to respond to drones that can cost thousands of dollars per shot. Another response has been jamming the signals that are piloting these drones, but that's becoming just as unviable. Advances in AI and imaging navigation have planted autonomy at the center of every drone fleet. That makes signal jamming impossible as a method of deterrence. One company's approach is to literally build a force field. Epirus was founded in July 2018 to push forward the use of high-powered microwave systems, or HPMs. Historically, semiconductors have been a key bottleneck in the use of HPMs, requiring too much power and often overheating. Epirus has taken advantage of recent innovations to make HPMs more viable as a response to drone warfare. The company's Leonidas system can efficiently neutralize dozens of drones without any collateral damage. Me and one of our senior research fellows, Krishna Ramamurthy, sat down with Epirus CEO Andy Lowery to unpack exactly how they're responding to the future of drone warfare. Andy, thanks so much for joining us. We're excited to jam with you.
Thanks for having me, Kyle. Excited to jam.
Awesome. Awesome. Well, listen, so as you know, Contrary Research, we pride ourselves on becoming the best starting place to understand any private tech company. And so the very first question we always want to get to hear from the horse's mouth is just give us the quick summary. What is Epirus? What's the elevator pitch on what you guys are doing?
Well, in a word, we've created force fields. I mean, in a word, and I'm not kidding. I mean, we literally create area sectors that we can put an electromagnetic field in place to deny the use of consumer electronics. And in the case of drones, you can put wide area shields, if you will, at like fence lines. We've seen a lot of news lately, New Jersey drones. We see about Langley, 17 drones. Put a system of ours at a fence line and you stop everything like a force field. So as far as version 1 of the Homo sapien humans inventions, we've invented version 1 of a human being force field. So yeah, we've created an incredible platform, and the type of company that we are as kind of a non-traditional defense contractor, sometimes I call us a neo-prime, it's taken that kind of company to push this sort of invention over the line. And we've done it, and now we have something that really is going to work well in a number of layers in order to defend different assets, bases, of course, but beyond bases, stadiums, refineries, ports, you can think of.
Yeah, I mean, I think that exactly what you're describing, we're going to unpack the product itself, what the market for that is, how the sort of trends are changing to shape the really strong need for that product. Before we dive into the details on Epirus, what I'd love to do also is walk through your background. You've obviously got a very impressive resume, a very experienced opportunity to be able to come into the company. But what I'd love to better understand is not just the sort of bulleted list of what you've accomplished in your career, but specifically if you could paint us a picture of your journey and how it led you to find yourself as the CEO of Epirus today. It would be awesome.
Oh, it's great, and so sometimes journeys, we always tell our stories narratively like these storylines, but it was a lot of haphazard kind of Mr. Toad's Wild Ride a little bit for me. I started out, and I guess in Illinois is where I'm originally from. And I say Illinois because the first half of my childhood, I grew up in Southern Illinois. And then the second half, I grew up in the Chicago area. And I left high school and I enlisted in the Navy right out. I didn't go to college. I didn't do anything like that. I went right into the Navy. And when I signed up, they told me, you belong in nuclear power. You should be a nuclear engineer. And I'll tell you, I didn't know anything about the Navy at the time or the military. I didn't even know they had nuclear power plants and reactors. That was a totally foreign idea to me. But I ended up becoming a nuclear electronics technician. And then I did really well in a lot of the different coursework and how I excelled. And so they offered me a chance to be an officer. And in the mid 90s, I got to go to University of Illinois, and I majored in electrical engineering, went back into the Navy, and I served as a nuclear officer aboard aircraft carriers. You can choose subs or aircraft. I went aircraft carriers. And so I did that for a number of years. And in 2002, I went into the reserves and started a civilian career, first at MACOM. Was a big part of my journey, where I learned a lot about high-powered amplifiers and that sort of thing. And then the next part of my journey, and maybe one of the most educational along my entire kind of job journey, was Raytheon. And I spent a better part of a decade running huge organizations at Raytheon. I got very lucky to be young and still able to run large organizations. I ran a whole portfolio of space programs. After that, I ran a whole portfolio of intelligence, surveillance, and reconnaissance programs. And then I culminated a career there as being the overall chief engineer in charge of all of electronic warfare for space and airborne systems. And I did that throughout the time that we bid on a very important program called Next Generation Jammer, which is sort of, I'd call him the father of Leonidas. NGJ doesn't have a cool name like Leonidas, but NGJ was very much a father to the concepts and the ideas around the approach that Epirus has taken later on to leverage things like gallium nitride and an arbitrary waveform generator. And then for the past 10 years, I've been in big data and a lot of augmented reality, a lot of computer perception, because the world we're living in, computers are becoming kind of aware of where they are in the world and what's around them, and then how to do a mission or navigate objects. And so this idea is common to things like augmented reality, virtual reality, drones, robots. It's this plethora of things like inertial navigation and other ideas that all involve the idea of computer kind of knowledge and perception and autonomy. And so when a counter drone CEO is on your show and you say the word autonomous, ask them, what's the first word to think when you say autonomous? I would answer swarms. You say autonomous, I say swarms, because really that's what that enables. What that really enables is the ability to attack with many, many, many different objects all at the same time, all thinking and moving and behaving completely independently without, I stress this, without any connectivity to the outside world. So traditional ways of jamming or disrupting or taking over signals that control will no longer be possible method of attack. You'll have to move into something that works differently in order to get into the electronics and do any kind of an effect other than an old kinetic shot, where you hit one missile onto one cheap drone. So my journey pretty much ended there, apart from getting a phone call from one of my old Padawans, Dr. Bo Marr, who founded Epirus back in 2018. Dr. Marr called me. I had called him back in the day when he worked at Georgia Tech. I hired him at Raytheon. So this time he turned the favor and said, hey, Andy, would you like to come join? And so I joined the company a number of years ago, first as the chief product officer is the first job I took. And I helped with some of the engineering and some of the work around the design of the system. And then a couple of years later, after taking that role, I ended up transitioning to the CEO. And I've been the CEO for a little while now. And telling you, this is it. This is the number one job. I told you all that career, Navy, MACOM, big Raytheon, startups. And out of everything, I can't think of a job that I would rather have than being CEO of Epirus. At this time and this urgency, this mission, This team of people that I have working for me, it is my dream come true. And I'm very, very happy to be in the role that I'm at. But that's my story.
Yeah. Well, and I feel like your sort of career and background, you touched on a lot of the aspects where this aspect of warfare has evolved pretty significantly over the years. And this is something that we've kind of noticed. We've done work with a number of companies that are either directly or adjacently working with the DoD, companies like Hadrian and Anduril. And one of the things that we see pretty frequently is that these companies are sort of by necessity defined by, 50, 60, 70 plus years of a sort of technological evolution, but also the sort of the DoD's willingness to work with certain technologies. And you'd mentioned a little bit, but high power microwave obviously traces its history back even to the research done in the 60s and 70s. And you touched on things like gallium nitride semiconductors. I'd love your perspective on what do you feel like are the sort of pivotal moments that have set us up for this to be sort of the perfect time for Epirus to do what you're trying to do?
Yeah, that's a really great question. The high-powered microwave, you're right. It's been around for a long time, starting way back in the 50s, 60s. They began to work with the technology, old technology, but nevertheless has a lot of incredible performance characteristics called transmit wave tubes. Some people call them vacuum tubes. And these older kind of vacuum-based systems that were able to take energy and boost it up. But here's the thing. It only could boost it for short durations of time. And when I say that, very short durations of time. So you may be able to get an old-fashioned high-powered microwave system up to just gigawatts of effective isotropic radiated power, EIRP, gigawatts. However, you can only maintain that gigawatts of power for the briefest interludes of time, maybe 20 or 30 nanoseconds. And because of that short duration of time, it creates a frequency spectrum. If you take the functional math, it takes a frequency spectrum and spreads it very wide. So that's just a principle if you're not an engineer, where if you take a short duration time, it gives you a wide set of frequency, and vice versa. Wider, more energy in a single frequency limits the amount of frequency. So they call that old-fashioned way of doing high-powered microwave, they call that wideband because of that idea that I just said. Where we came along and did something different is we took the idea of high-powered microwave, which conceptually is just the idea that we're going to push such a high, powerful microwave field that we don't need to come in through any open front doors. We can come straight into the wires and the connectors and to the boards, just because the energy field is so incredibly powerful. We're able to just come right in. Now, that's where the similarity of our system and traditional high-powered microwave systems stop, okay? We both get in the back door. But then once we get into the house and can get into the back door at whatever power level, then what do? Then what does the system do? And remember, the old-fashioned high-powered microwave system only can be inside for a few nanoseconds of time. They don't have a lot of time to mess around. They got to get in, they got to get hard, they got to smash something with a hammer, and they got to get out of there, because that's just the limitations of that type of system. What the Epirus system does is it's a high-powered microwave system that also is a high-energy microwave system. You have high-energy laser, you have high-powered microwave. Epirus is a high-energy microwave system. So that means when we get into the back door, we stay around. We hang around a long time at the party, making all kinds of ruckus, or whatever the word is, a lot of ruckus, making noise, disturbing things, messing up the way they think, the way they sequence, all this stuff that energy does. We're even at the tip of the spear of even learning the profoundness of the things that it can take over and take apart as you're inside of these circuits for a long period of time. So with that particular approach and with some cleverness on how we implement it with this arbitrary waveform software-defined system, where we can send in almost anything we can think up in MATLAB, we can get out the front end of our system. The combination of those two elements have led to this moment where you had a third element as well, which was, you alluded to it, is the gallium nitride progress that we've seen over the last 2 decades. So for your users that don't know, you have a substance called semiconductors. It was originally all silicon. And these semiconductors have very unique properties that could parallel some of those transmit wave tube properties that we were talking about, can amplify things, can do stuff. And forever we were stuck to just silicon. And then in the recent years, the recent decades, they've come up with new substances. Sometimes they call them 3-5 devices because they sit on either side of the periodic chart. Here's a fun fact for your engineers out there. The periodic table is labeled with the amount of valence electrons up in the outer shell. Well, silicon's up at 4. Well, you have some that are at 3 and some that are at 5, like gallium and nitrogen. Those two, you put them together, you have a 3-5 element. Same with gallium arsenide, same idea, 3-5. You get 3-5 elements that have a much, much lower depletion region energy, much easier to get over, and they have this inherent better performance. Well, gallium nitride came along and it became able to withstand enormous energies, enormous powers, enormous heat fluxes. Do you realize that inside a gallium nitride junction, there is a higher level of heat flux than there is on the surface of the sun? This is the type of magical rock this is. This is a magical rock. And gallium nitride has only performed better and better and better over the decades. It's, we for a little while joked around internally and we called it Mars Law for Bo Mars. Mars Law, because you have a similar idea happening where the processors, we're talking about more processors over time. Gallium nitride is getting higher and higher voltage, more and more power density. And if you look at the progress over the last 20 years, you see a trend that just doubles ever so many years. And Dr. Marr picked up on that trend and said, look at this, notice this, guys. And so right here was the line at which when we thought gallium nitride became significant enough that it could participate alongside the older technology in a fair fight, meaning we can get in the back door. But that's when the fight stops being fair, because like I told about earlier, a solid state device, gallium nitride, could hold that signal for a long time, 1 millisecond, however long. And all of that energy dancing inside the house after you get into the back door creates profound effects. And you push that energy into a large section of the sky because you put it all in a phased array, which is another thing the solid state allows you to do, is to stack all of these things up into bricks and create these scanned arrays that can scan the light. I said, when people don't know what I'm talking about, I said, have you ever been to a laser light show before? They say yes. You ever see a laser that draws an elephant in the air? Just one laser, and you see the elephant? That's how our system works. It can draw microwaves. You can't see them, but draw microwaves in a square, in a circle, in whatever shape we wanted to, but take up a whole section of the sky in just an instant of time. In less than a second, we can scan every single space of the sky within about 60 degrees by 60 degrees. So that's what puts up our field. It's a temporal field. Very quick temporal, though, that scans again and again and again. And that's what persisted, is that scanning ability of the front end.
You mentioned software defined. Can you touch on what have you guys been working on the software end, and two, what capabilities does that unlock that maybe didn't exist in previous generations? Like, for example, I know you guys have features where you can almost carve out zones in the air where you don't want to target. And I know that's part of your software. Can you touch on that a little bit?
Yeah, of course, we're using and leveraging many decades also of gallium nitride, gallium arsenide, and phased array. You look at Raytheon systems, lots of those are phased arrays. SPY 6 is a phased array. Next Generation Jammer is a phased array. APG 79 is a phased array. So when you look at the phased array capabilities, they're profound and mature. We can do things like notch out frequencies to make sure the frequencies that these blue drones are affected by aren't affected by our system. We can steer the beam very accurately and know exactly and precisely where that beam is steered, so we can steer away from those types of friendly forces. But in general, what we've done is we've done a system, again, similar to the next generation jammer system for the audience that have some familiarity with that, where on our side, because this is always a cat and mouse game. Let me start with that. People will ask just naturally, well, if you do this, why don't they do that? If you figure out a frequency to attack them on, why don't they change some shielding and move things around and change it so that frequency doesn't work anymore? Well, yeah, that's what they do. 100%, that's exactly how the game is played. So what they'll do is they'll see that I have this powerful system that seems to hit them this and hit them there, and then they'll change it by shielding or do something like that. But that does two things for me. One, it drives them back into the hardware because they don't have a jammer where they're going to use encryption or signal processing to get around me. They're going to have to get into the hardware. They're going to have to put heavyweight shields, different things that weight down the drone that the drone might not be designed to support, and very, very manual processes. Things like putting like globs of RTV, which is this like jelly that resists radiation. All of these things they have to do, which drives them to lesser and lesser capability to build, lesser and lesser volume, puts them more and more into the military lane, brings them back to our playground where we do all the real damage, right? It brings us back into our lane where DoD is by far and away the strongest. Consumer electronics lane, China, we've given a lot of that keys of the kingdom to China. They own a lot of strength in that category. But in the DoD lane, we still hold and run supreme. So what Epirus has done is built a machine that drives them back into the military lane of weapon systems because we deny anything that's simply and cheaply produced with consumer electronics. And when they change their electronics, let me give you the cherry on top of this question, we change our system. But we don't have to change the hardware of our system. We just reprogram it. And that could take us minutes to days, but not more than days. We've not had an experience where it's taken us more than days. We've been able to pick the lock, but we've been able to do it in minutes or even seconds as we have the system in real time and we're running through kind of a whole sort of litany of different magazines and different techniques that are doing different things. And the system then has many tools and hardware tools that we can kind of play the guitar. We can do polarization. We can do different frequencies. We can do different pulses, different pulse repetition rates. All of these things are part of the equation, a very complex, very complicated equation that we can leverage so that our cat and mouse motion is just software. It's just a software upgrade.
And I think that frames the picture really nicely about as conflicts are changing and people are sort of making specific changes to their hardware, especially to your point, you talked about there's a massive onslaught of consumer drones being used in military use cases. And so you're sort of zeroing out a lot of that sort of high volume, low cost capability, forcing it back to this has to be a sort of military creation that we're dealing with. Before we jump into the changing face of some of those conflicts, one of the things I think would be helpful to get the visualization from you is we've touched on a lot of the sort of core enabling innovations around the Leonidas system. What I'd love to better understand is how has that product evolved? Obviously, from the core stationary system, you now have several other form factors from mobile and the pod. So maybe you could walk us through sort of what the surface area that your products are covering, and then we can dive into some of the things that are changing.
So today, again, we're in generation 1 that we're sending the Army now. We call that generation 1. Now that generation 1 was preceded by several prototypes. We almost build believe it or not, even though it's very expensive machines, we build these almost like a cellular phone company builds a cellular phone, where they implement a process that's known a lot in the industry as something called an EVT, DVT, PVT. And so we spent a year or so building our first engineering verification and test article. That was our first prototype. And then we spent a couple years designing several iterations of our design verification and test article. And that involved a lot of what we call soldier touch points and a bunch of things. And we ultimately landed on our generation 2 system that we're right now in build of. So the generation 1 system's deployed. Some are in the central command and some are going to Indo-PACOM somewhere. I can't say where, but they're getting deployed now, the early prototype version. The next prototype version, which will be our final prototype prior to program of record, we're calling Generation 2. And those prototypes will be much, much more capable systems. Those systems are going to run on batteries for one. They'll have a huge amount of lithium batteries that'll be able to burst a lot of energy at a very peaky type of motion, because we'll want a lot of peak energy over time. So it will leverage that. It'll leverage diverse polarizations where we can change or select the polarization depending on the target we're going after. And we found the right polarization against the right system creates quite a profound pairing. We've been able to increase the total pulse width of each of our pulses. We've been able to increase the duty cycle under those burst periods that I was talking about. And all of those additional features are going to be part of the new system that's going to really, really elevate sort of our range. So we have like a low end range and a high end range because we're away, we're a field. So like as things enter the field, they have different susceptibility levels. And as they become deeper and deeper into the field, that susceptibility becomes more and more kind of ferreted out, right? So like if it's a super non-susceptible system, it might get in, pretty close, not too close, still hundreds we're talking of meters, not like, right in and a few meters away. But nevertheless, it gets in pretty close. Well, we're trying to continually extend that bottom range, that bottom end range. We're trying to push up and up and up. And by doing the things I just alluded to in the lab, as we run experiments inside of anechoic chambers and different chambers, we're able to see a very, very extremely measurable increase in our ability to kind of have effects at a much longer range with Generation 2. Generation 3, which is kind of just being discussed and talked about, has a lot of new features even beyond that, including new gallium nitride that we're working with MACOM on that may even kind of eclipse the highest gallium nitride in the world today. They've built a system or a device that is even higher. And so we're talking about something around 3 times potentially the power density of the current system per individual brick. So we have about 150 of these bricks. So about each of those individual bricks will be 3 times the power in the Generation 3 system. And so we constantly try to get EIRP up there better and better, and that's delivered through more and more power dense gallium nitride in these devices, but then also just increasing the size of the system. Like if we elect to do a 20 by 20 system, it's going to be a much more powerful system than a 10 by 10, for example, as we scale the system up and down. And since we've got that kind of core foundational IP done and established and working and reliable, we've been able to scale it, everything from like a 6-element system that we're talking to the Army Futures Command about making it backwards protection for the Abrams tanks against first-person viewers coming in and hitting them into Ukraine from the rear, all the way up to the big base protection and getting those larger and larger to kind of protect ports and other sort of ideas and other sort of vectors for attack that folks have had. It just depending on what, like if you're defending the north and south of Taiwan, you probably want to go out a couple miles at least, if not further. You need a bigger system. But the system is very parametric that way. You can make it big as long as you can contend with the size, weight, and power requirement. Shoot. You ever hear of something called the pave pause system, Kyle? That's an old system designed in like the 80s that was an early warning radar. The reason why I know about this is MACOM provided the silicon bipolar, remember before we were talking silicon bipolar L-band devices that produce the transmit power for that radar. Well, if you Google that, pave pause radar is a building. It's literally it's a round radar that's the size of a building. Well, if you put a size of a building, Epirus Leonidas out there, you might have 15 or 20 miles of effective range that you could push that beam out to. So that's, obviously a lot of work and engineering to get that big of a system put together. But nevertheless, if you're thinking about north and south of Taiwan, you could put systems of that size and pave pause size and capability. You might have 20 miles of protective coverage of the north and south of that island. So lots of different opportunities. The system is very parametric. We've run through a number of iterations where we've learned more and more about energy and just how important energy is over just straight power. Just straight power is good, but with great energy comes a great system with a great number of effects that are much more powerful and much more lethal than traditional high-powered microwave.
Yeah. One sort of specific question on the evolution of the product. Is there anything that you have shared or can share about how you think about the timeline, whether that's when Gen 2 will likely be deployed or the sort of longer term path to Gen 3 being deployed?
Yeah, Gen 2, we're building. We're like, if you were here at the factory today, you'll see some of the initial steps going on to build 4 Gen 2 systems. So we're in process of build there of 4 systems at least, unless we get the word to order more. That we may do with this new administration. They've been talking pretty seriously about that. And then the Gen 3 system is dubbed, that's the program of record system. That's the system that's going to be the catch-all to all the soldier touch points, all the learning that we're going to do over the next couple of years as we deploy these prototypes, the Gen 2 prototypes. And that'll become the Gen 3 system. The Gen 3 system, likely program of record in 2027, if not sooner. If not, an acceleration button gets hit again. Right now, I think we're angling for 2027 and on track, hopefully, knock on wood, on track to continue to deliver so the customer gets enough confidence in us to push us forth and push us into the regular PEO lane, which is the ones that'll run that program of record.
So, and you touched on expanding both the sort of power and range of the product as it evolves. One question that I have, and then I want to turn it over to Krishna because I know he has some thoughts here as well. But one of the questions I have is, if I were to map that onto what are the areas that maybe today you're not addressing that you think you could address as the product evolves, whether that's, you think about when people visualize drones, I think they visualize everything from these sort of, several $1,000 consumer drones that have been strapped with a payload pretty haphazardly, and then sort of the more sophisticated drones. But where on the spectrum do you guys feel like today maybe you tap out and there's certain complexity your product can't address, but over time could expand to take care of?
So I think what I'm going to go with here is more consumer electronics applications. And then obviously I might talk about the application of defending against a wide-bodied aircraft, and people can assume what they want to assume there. But I'm not going to mention anything about higher ordered targets beyond consumer drones, even though, that is a possibility, and there has been some profound discoveries, but these discoveries are now kind of cribbing into kind of like a little bit of dangerous waters here with wanting to say too much. So here's what I'll say. Okay. The tail end of your question was, what other applications and targets? So, okay. So beyond drones, we have a lot of other, of course, anything consumer electronics related will have like a computer on board. If you let's look at like a outboard boat motor, for example, of an engine. We took a system out, a smaller system, but albeit powerful. We took it out to a Navy exercise this summer and worked it against a bunch of boat motors because USVs are becoming just as problematic in the Ukraine-Russian war as the flying drones, the ones on the water, I mean. In fact, there's an interesting fact that was told to me not too long ago that 50% of the Russian Navy has been damaged or destroyed by the Ukrainians who have no Navy. And so there's no wonder that both Putin and Zelensky have now decided to create drone branches of their armed forces. Okay. So USVs are just as threatening to the Navy as the drones are to the ground and short range air protection fight. And good news is Epirus is here once again with our force field. So you push a force field out to an outboard motor and it knocks it offline. And the only thing to take it back online is a hard reset where you take the key all the way off and all the way back on. And again, we're talking hundreds of meters. We're not talking tens of meters or less. We're talking hundreds of meters. So you can imagine Coast Guard cutters or other ships that can defend themselves and other squadrons and ships and everything else from these type of USV attacks, but also have it against close-in drones and other flying type systems. Now, one of the things that I want to say a little bit about when it talks about higher ordered products or other targets is a lot about the class of effect we have on the systems, because you have a typical effect of a laser system will be called a level 5. And that's where they burned a hole in it. Like there's no getting the drone and rerunning it or any of that. It's broken and it's dead. And then there's the level 4 effect. And most of our effects end up, because of the high energy effects, they end up being level 4, which means it requires a hard operator reset in order for the system to come back online. So for a drone, that's a death sentence because it, of course, falls from the sky and crashes and breaks on the ground. But for a boat motor, you can take the beam off, the operator can turn the key all the way off and then all the way back on, and the boat will begin to run again, which for a ton of applications, that's a better level kill. Now, the third level, level 3, again, it's getting less and less. Level 5 is kill it dead. Level 4 is hard reset. Level 3 is you have some more subtle effect. And those can be almost on the border electronic attack ranges, where we're looking at maybe kilometers and kilometers out, where you're making subtle attacks on some of the electronics that do subtle things. And a good example would be, let's say, an ISR camera, a commercial camera, on a drone that's there to do some spying. Well, we might have an ability to make the camera look like it's got white fuzz on it from many kilometers out. But then when the drone isn't going to take effect until it comes within maybe a kilometer or something in that range. You see, so there's level 3 effects that can be pretty profound and begin to incorporate other targets beyond just the motors and the wires and the ailerons of a drone. So yeah, we are after drones right now because it is the threat that is the most material and the one that's most threatening and the most prevalent. But we have, as we talked about in the software definability of the system, just a complete ubiquity against any target that has consumer electronics or any really computer-like electronics, sensitive electronics in it. Anything, even if it's militarized, is susceptible. There's nothing magic about the IMUs inside of a seeker. They're not special IMUs. They're susceptible like a consumer IMU. So all of these things could be potentially vectors for target for future systems on different applications on board different types of systems. You know, you can think aircraft, you can think airborne, you can think space and what's going on in space. It's the type and sort of breadth of the platform is akin to like force fields. Like I keep saying that as a joke. I once had a person, I won't say who to spare them any embarrassment, but they said, well, is what you doing at Epirus a platform business? And I said, sir, with all due respect, we've invented force fields. Do you understand what a platform is? I mean, yes, it's a platform. It could be worked into space applications, into airborne applications, into surface applications. Subsurface, I got some thinking to do because the waves don't go so well underneath the water, except if they're super low frequency, which we're not nearly low frequency enough to get working underwater. But above water and up, we're good to go. In all land, air, sea, space, all of that, we're good to go. So it's got a ton of applications, both in the military lane proper, but in outside the military lanes as well, like we talked about earlier.
So you kind of touched on this already, regarding program of record in 2027 and a few of those other things. But kind of, could you walk us through, for our viewers who aren't familiar with like how the Defense Department works, kind of how do you work with the DoD? And obviously, you guys are putting your own money into the R&D and things like that. But can you share, a little bit about what's driven your success? Obviously, you guys, Anduril, Shield AI, you guys are all kind of pioneering this, like kind of moving away from cost plus and taking on more risk and things like that. So if you could talk about that. And then also, if you see any potential for, partnerships with some of these other defense companies, whether it's, putting a Roadrunner into like the back of a Leonidas system, or if you can share anything you guys are doing there, or, any thoughts you might have there.
You may or may not have heard of this before, but back in 2017, the Secretary of Defense at the time was named Ash Carter, and that secretary came up with an idea to implement something called the Adaptive Acquisition Framework. And he basically allowed the DoD to, in certain circumstances, flex away from the FAR, get away from the federal acquisitions regulations, and do stuff with a little bit more agility and nimbleness. And he called that, and obviously they needed law and policy in order to do that. They call that law and policy the adaptive acquisition framework. And within the adaptive acquisition framework, there's a number of ways that material can be bought, things can be bought by the DoD, and it has a whole bunch of different categories. The category that we're in is a little different than the category that Anduril's in, or the category that Shield AI is in. The category we're in is what they call a mid-tier acquisition. And what an MTA does is it basically allows for a hybrid between a traditional defense program, which needs all of the rigor, all of the support, operation sustainment, training, a whole ecosystem, laboratories, and like a Patriot missile system. Like, you need to have an entire Army ecosystem in order to support building, fielding, repairing a system like that. Our system, being a force field generator, is akin to that. It's going to need to find its way to the FAR eventually. Systems like a Roadrunner or other even very sophisticated, incredibly impressive technology is still considered, though, to be dual use. And by considering them to be dual use, they can do a lot of their sales can be commercial off the shelf. You know, they can't sell it maybe with a weapon payload, but with taking a kinetic payload, those roads have been plowed. They know how to get Coyote payloads into country. They know how to get them exported. Those have been plowed. The directed energy roads have not been plowed as hard. And so therefore we're plowing. We're doing the plowing through a process called a mid-tier acquisition. Now, you're only allowed to do a mid-tier acquisition if you have a very urgent material request. And so by luck, we're lucky that the drone problem is so big because it's issued a trigger that allows them to flex and do a mid-tier acquisition. And so we competed for the mid-tier acquisition in 2022, and there were 5 other competitors. And of those 5 competitors, we won. We won the prototype shoot-off, and we went to the JCO to do this, by the way, under right now General Stevens down there. And before it was General Thurgood, actually. No, he was Richter. I'm sorry. He made the selection to the JCO. I forget the JCO. I think it was General Gainey or something. So when we were doing the JCO event, General Thurgood by Richter said, I looked at all of the different systems out there, and we want to elect to go with Epirus. So then that triggers the RICTO, Rapid Capability Technologies Office, to do a buy, try, decide process. And we went through 15 months of try. I didn't know try would be so long, but we've run through the gamut. We've done everything: people safety, fratricide safety, DRAP processes, performance processes up to wazoo. Red team, blue team scenarios where they're separated, no one knows what everyone's going to do, and they're operating the system like they're in the Middle East. And now, as a final step, the cherry on top of the sundae, we bring it to CENTCOM, to INDOPACOM, and we do a final operational exercises that everybody gets the confidence that these things are as good as they say they are. And once that happens, program of record is kind of a sure thing. As all that happens right, it's a sure thing. And we should know in 2025. We should really know in 2025.
Yeah. And also, I know you guys aren't just a defense company. You know, obviously your smart power technology has a lot of application. Could you kind of talk about, like where you guys are mainly, what you guys are mainly doing in commercial, and then secondly, future use cases for your smart power technology?
Yeah, sure thing. And as I lead into that, I'll talk a little bit real quick. You know, Palantir and Anduril very much are brother companies to us. We're in the family. We're the little smart brother, I guess, that knows a lot about microwaves, but we're in the family. And so when you talked a little bit earlier, the second part of your question earlier, you said, well, tell me a little bit more about the linkage you have to Palantir and Anduril. Well, it's tight and it's strong. And we're brothers fighting the same fight, not against the primes, but just a different category. So we have to make room for ourselves. We're a different category. We're giving a different option to the DoD. And therefore, you know, numbers provide strength. And so recently there was a leak of this sort of activity going on with Palantir, Anduril, and some others. Well, we're very much in that brotherhood. You know, that's our team there. You know, Sham and Chris Brose and Palmer and all that, we're very close personally. You know, we work together. We talk about things. The lawyers all talk with one another of the various companies to figure out the best ways of going about doing this. And for the most part, that one voice kind of boxed together is very powerful, becomes very, very powerful, like on par with some of the big primes. And so I think that that's a neat thing that just in the last part of 2024 kind of began to develop. And I think you're going to see a lot more of that in 2025. Okay, now I'm going to pause and answer your second question. So as far as the consumer electronics go, so when you look at Epirus in every kind of way, Epirus is a hybrid in a lot of ways. And when it comes to like being a neoprime or a traditional prime, if you look at the construction of the team, we very much look like a program office out of Raytheon or Northrop Grumman. We have chip and wire, we have a system level, we have software level, we have system of system people. We have the whole gambit like a program office of engineers. And therefore, as we're assigned to these high-tech projects, we can do just a lot of different things. And so one of the things we've done whilst we created these is we've really learned a lot about power storage and then power conversion, especially when it applies to gallium nitride and high-powered RF. And so by learning a lot about that, we've made a lot of innovation and discovery in the transmit chains. And what we've begun to work with, our first kind of prime partnership has been with L3Harris. We're looking at their transmit chains on the transmit side of the radios, because a lot of those radios, they get hot when you try to use them, or they can't withstand a lot of battery life, or they don't support certain signals because they're too complicated and they don't have enough efficiency to carry them. Well, in all of those kind of categories and situations, our technology solves for that. It solves for the coolness of the radio, the size of the radio, the weight of the radio. It makes more signals possible. It makes your battery life a lot longer. All of those things are things that we are just really global experts at. And so from that point of view or that perspective, we can embed, we can sell modules with this embedded technology in it. As a consumer motion, as a commercial motion, make a higher net income, a higher gross margin business in order to help support some of the net income needs that will be required to maintain a kind of a position as a neoprime, where we have healthy gross margins, healthy net income, and we reinvest that net income into innovation. Because your aforementioned question about like you did, yes, we've invested hundreds of millions of dollars into commercial IP. Yes, we have a category 18 ITAR weapons on the weapons list, weapons system, but it has been commercially derived. We have commercial patents protecting the way we've done this and the way we're coming to market. It's not a military rights system at this point in time. Now, some of the rights we gave to IFPC HPM flex into the Army in a certain way, but the commercial system, the Leonidas system, is 100% derived by our own money. And so there are some uncharted territory we're in a little bit. Like, I don't know what that's going to mean for the future. Like, I'm not opposed to Raytheon and others helping out and building force fields alongside me. I think Raytheon, L3, there's a few other companies out the Northrop, maybe even Thales, could do an excellent job, I think, with the right know-how on how to build these types of systems. And I'm not opposed to more competition being out there. But the future is a new one. It's a new path we're on these days, and we're doing things a little bit differently. And now with this administration coming in, I think we're going to do things a lot differently. And so I think we may be in some new ideas, some new changing times. Change is always scary, but at the same time, change can bring about a lot of good. And so I'm looking for a little bit of both going into this administration, but leaning into the good stuff. Not into all the scary stuff that people talk about too much in the news. So,
well, and that's a perfect segue into the last question that I want to ask you. We always like to end with this sort of, dreaming the dream and potentially dreaming the nightmare scenario of the future of the business, right? And maybe we start with the sort of key risks for you when you think about some of the things that maybe keep you up at night, right? Whether we talked about some of these countermeasures that folks could be developing in response to your technology or whatever it might be. What are some of the things that you're very cognizant of and sort of watchful of as you try and make sure that your business is future-proof?
Well, one is IP protection. We need to protect our IP strong. as an IP-based company. All of our IP is Epirus owned, and we need to own that IP. That's part of the differentiation between us and a neoprime. I think, not neoprime, it's between us and neoprime and a standard prime is the difference, is that we are an IP machine. Like when you look at the finances of a prime, you'll see a top line number, you'll see a gross margin number, you'll see a net income number. And when you see a very close gross margin to net income number, you know there's not a lot of personally funded OPEX in there. And so we need to have a good differentiation between gross margin and net income, because that means we have a lot of R&D OPEX. And so we need to continue to fuel that engine. And my biggest worry is we have such a supreme platform of a business that we're going to get sucked into a cost plus type world. And we're going to end up might as well get bought by Raytheon at that point, or Northrop, or L3, or GD, because we're going to look a lot like a fear that will look a lot like a normal prime. I think that's really, if worst case scenario happens, we look like a normal prime. We're at a point where this tech is so proven and so viable that I think we're going to win at some level. I consider it to be a little bit of loss if we end up having to bow and say, oh, yes, sir. And of course, if I'm talking to you in 2 years from now and I'm getting bought, I'll be like, oh, no, this is a better idea. But for now, I'm telling you, tried and true, the best idea for me will be to stay independent and not to be similar to the prime, work with them very, very well, like I used to do. I used to be a prime. I know how I work with them. But at the same time, be that 21st century skunk works, not a skunk works or a phantom works under a Boeing or a Lockheed, shielded, pure. Straight into the customers, straight into the Department of Homeland Security, straight into the Army, straight into the Air Force. Have that ability to access a highly technical team, one that has a great ability to do whatever they need to be done. This urgent issue. I dream of that. I dream of being in a way, a Stark Enterprises or a Batcave from Batman, take your pick, where the government comes to us and says, Andy, I'm in an urgent pickle. We've got this new thing the Chinese came out with, and we don't know how to solve it. We're here for you, sir. We'll get it solved. That's the Epirus I look to build. That's the one that I want to see for the future.
I love that. I think that's a perfect place to stop, and excited to have you guys on the case trying to build that. I know that it's a critical need now, and you've already spoken to the urgency. So we appreciate everything you're doing and appreciate you taking the time to chat with us.
Thank you. Thank you for thinking of us and reaching out. I really appreciate all the work you guys are doing and your interest in Epirus.
Great. Thanks, Andy.
Thanks.
Thank you.